Okay, this is 1.2c, continuing with 1.2, talking about the domains of functions. And we're going to look again at the one I just had up here. G of x equals the square root of x plus 5. Okay, so remember, this letter here is only there because sometimes I may be looking at two problems here. And so that you don't get confused, they'll use an F on one of them, a G on the other one. It doesn't make any difference. It doesn't change what you're doing. They're just using a different letter once in a while. So there's the letter. And they're saying, okay, let's look and see if these work. Let's look at G of 16. So that means we're going to put 16 in there. And we get 9. Okay, that works. 9 is a possible answer. Let's go ahead and put negative 7 in. Okay, problem with that negative 7 is negative 7 is not a real number. Okay, it's an imaginary number, so it doesn't work. So negative 7 is not in domain of G. Okay, so that's what you would write. Inputs that make a denominator 0 or that yield a negative radicand in an even root are not in the domain of a function. Write that down right above example 9. That's how you can tell whether or not inputs are in the domain or not. If they are not in the domain, it's because the denominator in a fraction is 0 or the root is negative. Those are the two times where you can say that those numbers are not in the domain of the function. Alright, so example 9. Find the domain of each of the following functions. Okay, so again, if it's not in the domain, that means the denominator would be 0. So what number makes the denominator 0? A 3. So 3 would be a number that would not be in the domain of real numbers that we're looking for. So it's kind of like you're looking for what doesn't work. So the answer would be written in set builder notation as x such that x cannot be 3. So all x's such that x cannot equal 3. So that's the domain. All x's except x is 3. Another way to write this is using union, and that says that all numbers from negative infinity to 3 work, and all numbers from 3 to infinity work. Okay, one of the things that I want to share with you real quick, a rounded parenthesis means not inclusive. Okay, so this means, like if I had 0 to 4, and I'm going to put a box around that one like that. This means that the numbers that work are between 0 and 4, not including 0, but including 4. So the bracket means that it includes this number. The rounded means it does not include this number. And since we can never get to negative infinity, it doesn't include negative infinity because we can't get there. It also does not include 3, rounded parenthesis here, because 3 makes this undefined. But it also includes numbers that are bigger than 3. So it includes all numbers less than 3 and all numbers greater than 3. Okay? You could also write this as x such that x is less than 3 or x is greater than 3. Okay. Okay, so it can't be 3. That's the key thing. You're trying to show all the real numbers out there that do not include 3. Okay, so that's what they're doing with all of that. And I know this is a lot of really, really boring, yucky stuff, but it's stuff that you need to be familiar with so we can continue going here. Okay, so B, g of x equals the square root of 3 minus x plus 5. All right, so what can x not be? X cannot be a number bigger than 3, right? If x were 4, we'd get the square root of -1 plus 5, right? Can't have a negative radicand. So the numbers, the domain that works are x such that x is less than or equal to 3. Whoops. Because if it's a number bigger than 3, it's going to make what's under the radical a negative number. You could also write it as negative infinity up to and including 3. But it can't be bigger than 3, but it can be 3. So that's why I have the boxed parenthesis here to show that it can be 3, that I'm going to include it. Okay, so that takes us to C. And C says h of x equals 3x squared minus x plus 7 over. We don't even care what the top is. All we care is the bottom. What numbers are going to make that 0? Because those are the ones we don't want. All right, so plus 3 minus 1. Okay, and then we have whatever we had up there. So x cannot be -3, nor can it be 1, right? Because either one of those numbers would make our denominator 0. So if we wrote it in set builder notation, it would look like this. The set of all x such that x is not equal to -3 and x is not equal to 1. Okay? If I were to write it in coordinate, I don't even remember the name of the way we write those, but if it can't be -3 or 1, it can be negative infinity up to and not including 3. From -3 to 1, but not including 1. And then from 1 to positive infinity. So it can be 3 different parts. It can't be 3, or -3, and it cannot be 1, but it can be all numbers less than 3, or -3, numbers between, and numbers greater than 1. Okay, so it can look like that. All right, so let's look at D, and then we'll be done with this little section here. F of x equals x cubed plus the absolute value of x. All right, so you can put any number you want in here, and you're going to get an answer, because we're not worried about a fraction, and we're not worried about a radical here. So it doesn't matter. If we don't have a fraction or a radical, then the answer is the set of all real numbers. Everything works. Or we can write it this way. From negative infinity to positive infinity. Okay? Alright, so let's jump down to example number 10. And they want us to graph these. So I'm just going to real quickly go through some of these. And so you've got that one there. And pretty much what you're going to do is you're just going to do this again. Okay? And then you're going to graph each one of these. All right, but what I do want to do is focus on C for a minute, because it's a fraction. F of x equals 1 over x minus 2. What can x not be? X cannot be 2 when we graph this. So I do my thing here, and I start putting numbers in, and I end up with a graph that looks like this. And notice, that's 0.2. That's the 2 that this cannot be. So the graph goes and then straight down into infinity and straight up into infinity, but it never hits this point, this x point of 2 right here, because it can't. It's undefined there. So it will never touch that. And that's just very important to remember as you're doing these. Okay. So applications of functions, which is the last part of this section. They give you the formula for the speed of sound in air. So they give you the S of t equals 1087. And you don't obviously have to understand what this all means. Over 2457. So there's the formula. So the speed S of sound in air is a function of the temperature in Fahrenheit, okay, and gives you that formula. Find the speed of sound in air when the temperature is, okay, there's the temperature right there, the T, is 0, 32, 70, negative 10. So you're going to do this 4 times. So you're going to put a 0 in here. So S of 0, temperature, 0, equals 5 times 0. So this divided by this times that will give you the speed. So 5 times 0 is 0 plus this. So this over this is 1. Square root of 1 is 1 times that. So the speed of sound in air at 0 is going to be this fast. As we raise the temperature, the speed of sound is going to go faster. So let's say it's 70 degrees. So we're going to put S of 70 here. Put a 70 here. 5 times 70 is 350 plus this divided by this. Take the square root, multiply by this, and you're going to get 1,162.6 feet per second. Okay, so that's what you're doing with the applications. You're just taking a formula that they give you and plugging the numbers in. Okay, but just don't forget to put, so if you're doing it at 70 degrees, you're going to write it at the speed of sound given that the temperature is 70 equals 1087.7 square root of 5 times 70 plus 2457 all over 2457. And then you're going to solve it. But the key thing is don't forget to start practicing putting in what you're going to substitute in for t. Very important down the road. So that's it for 1.2.